Hello everybody, my name is Craig Bennett, and today I'm going to do a one-on-one video for 3D printers. Now the big thing to note is this is meant more for to getting some fundamentals on 3D printers and things that I wish I knew before I start in. Otherwise, this not knowing some of these things actually cost me hundreds of dollars trying to fix it. And some of the problems I'm still trying to fix even to today. And I've been better off if I knew some of these things. So real quick, something that really doesn't matter one way or another, but something that's interesting to note is you got several different type of 3D printers: FDMs, SLA, DLPs. These are more what you're going to see in home use, more so in the FDMs. Then you got powder and metal. You also have ceramic and a few others. But a big thing to note with the metal and ceramic is you need a kiln. The big thing to note with those is the cost of them. You're talking about a couple thousand, like $5,000, $10,000 to $20,000, and I've seen powder printers easily cost within the $200,000 to $500,000, $200,000 to $500,000. So it can get very expensive very quick. So the bulk of what you're going to see from home use is FDM or SLA or DLP. So SLA, DLP, FDM, SLA and DLP. I'm not going to really get into the difference between those two, but the big thing to note is SLA and DLP has a higher resolution than FDM, as you can see here, and also as you can see here. It's just physics. There's no way around it. And how does SLA and DLPs work? I'm not going to get into the nuts and bolts. There's plenty of material out there if you want to research that, but basically there's a resin tank, and then you got a build plates, and what you have is something that projects the light. So long story short, basically you have a resin that cures amongst certain light conditions. Might be UV, might be blue light, might be something else, might be laser, might be whatever. Basically the build plate would be all the way into the resin tank, and as it rises, the configuration of the light would be different. And what would end up happening is you will have a part that's printed off. It'll harden the resin as it goes up. Hopefully the resin part doesn't fall off the build plate or whatever. That does happen. And basically what you have is a 3D part. Problem with this, and thing to note, is the build plate moves up with these. Problem with this is the build plate, you have to take that off, put it into a bath with the 3D part. Normally this is an isopropyl alcohol bath, and then you're going to cure the part. And if there's any hollow spaces inside, when you model it, you need to make sure that there's a small hole for any unused resin to come out on. Otherwise you will have problems later on. So basically you're going to have to, after you're done 3D printing it, take it over to a bathing station, cure it, and should be good to go. It's very messy. So with this, you do get a better print, and that's just the physics of it, the amount of space it can fill in and all the others. Then you can print stuff in much higher detail, jewelry, engineering parts, stuff like that. And then because the items are much higher quality, they can sell for a lot more, so jewelry and stuff like that. So the problem with this is it's very, very messy. You're dealing with resins, you're dealing with bathing stations and curing stations. It's 40 FDM, print it, take it off the build plate, and we're good to go. Maybe there's some cleanup, but it's all hardened stuff, and you don't need to have gloves on, you don't need to have anything else. So with this, it costs a lot more. We're talking about a lot more for the printer, and also for the resin amount. An ounce of the resin material versus the ounce of the FDM is a massive difference there. So some resins are toxic, and by toxic I mean you can get cancer, or it's carcinogenic if they touch your skin. So note that, and note that it does create some smell and fumes. So mixture between that and the other, you got to wonder what is going to be going into the air. So this is a big thing to note there. So a big thing to note is all SLAs and DLPs that are affordable for most people are going to be very small and build print area. If you want to make something worthwhile, like a worthwhile size, you're going to spend a lot of money, and most people just ain't gonna have $10,000 thrown down. So, and by small, I'm talking about tiny. Like you could look up some of the numbers, but with FDMs, I can print. I don't have a printer that does this, but you can easily get a printer that prints, say, a meter by meter cube. You're going to pay a little bit, but for about the same amount, I can get the SLAs, but it only prints, a couple inches by a couple inches, depending on the printer. So it's a big thing to note. Now, less people use this, so there's less people to grab information from. This is a FDM printer, and basically the way to think about this is filament goes down, goes in, and it comes out. It goes layer by layer. Think of it like a hot glue gun, building layer by layer. That's the best analogy I can give. You got a build plates down here, extruder up here, and it goes upwards from there. Sometimes the build plate can go down from the extruder, but more than not, what you're going to find is the extruder goes up and whatnot. So best way to look at it is like this. Again, it's layer by layer. And the big thing to note is these little crevices and stuff like that. Because of that, none of this stuff I'm going to say is really food grade. You can get food grade filaments, and I don't know too much about it. It might kill off the bacteria or whatever. If it does, great. If not, then something you need to note. But a big thing to note is bacteria can hide in these places. So you might want, like regular grade filament, you want to stay away from using as food materials. You can theoretically get away with powder materials, dry powder materials, because bacteria needs water and all that. But a big thing to note is you really shouldn't be using this stuff for food grade. Even if it's food grade, this stuff, the printer itself, probably isn't food grade into itself. So realistically, it won't. Yeah, okay, to film it, you spent $60 on it to make it food grade, but you just took away that ability because what it went through was not food grade. So yeah. So big thing to note that. Now, one thing I forgot to mention into these slides is the FDM. One of the problems is the filaments love water. They'll soak in water. After you print, it's not really a problem at all. But stuff like nylon, 48 hours, and you got to bake it in the oven to get the water out. You got to do backflips to get some of these things to not have water in it. So it's a big thing to note there. So pros is it's cheaper. It's not as messy as I mentioned before. And you got a large choice. I can print with carbon fiber material. I can print with wood, like literally have wood powder, metal powder in it, or glow in the dark, or flex material, or whatever. Whereas SLAs and DLPs, you're talking about resins and only resins. Obviously, you got a little bit of variance in there, but for the most part, it's it's resin. So with that, there is a lot of bad printers. A lot of them from shady places. Watch out for them, especially with the with that, because the thing is if you buy something that is not from a reputable source, it can cause a fire and problems happen from there. Basically, what I would say is go and find something that you want to buy, and then ask around, is this a good printer? Ask questions like, has anyone noticed if this company has shut off any safety features in the printer? Because sometimes what happens is the motherboard itself will actually have, that's a standard across the board, it has safety features built into it to prevent some thermal runaway or whatever it may be. But the manufacturer that will be building the printer itself will turn off these safety features in order for the printer to work at all. So this means that if you messed up building the printer, given a got-in kit, or whatever it may be, then you can have a fire. So you might want to avoid those companies if all possible. What I found is more not China is tend to be the area that you got to watch out for. Philippines, stuff like that, same thing. You got to watch out for those areas. But even the United States, there's not too many good printers that's coming out of the United States. Hopefully that changes. I really hope that changes, especially with the shipping and stuff. But as of right now, that's the only reason why I didn't buy anything from the United States. I can't find anything worthwhile, unfortunately, when it comes to printers. So that's a major thing, is safety features. So then there is more parts that mess up. It's more mechanical things to deal with, so more things can mess up. Then you got physical hard limits, so sizes and whatnot. Stuff goes with that. And the smell for some can be bad. Now, the big thing when it comes to the filaments is if you buy filaments, try to make sure that they're coming from the United States or Europe. The reason why is, you can buy stuff from other places, but unlike the printers itself, United States has some of the best filaments you can ever get. I think it has something to do with quality control in bulk of the places that buy industrial versions, the filaments and whatever for industrial versions. You can get it out of Europe or United States, and reputation means everything. Whereas if you look at places like, I'm not saying everything coming out of China is horrible, or Philippines or whatever, but the thing is let's take China for example. The milk powder incident. So for those who don't know, basically a long time ago, some company, they put some crap in some milk powder to trick the machines thinking there's more protein into it, which caused cancer and kidney stones. I don't think cancer, but caused kidney stones, death and whatnot into little babies. And because of that, even to today, smuggling milk powder itself and chocolate is more lucrative into China than heroin itself, believe it or not. And even at that, many of the Chinese people, given that they're not, poor, they try to buy food from outside of the country if all possible, with the exceptions of knowing if someone got the right thing, because yes, they got some type of safety regulations, but the corruption's so bad that safety is basically off the charts. It's just so bad there. Hopefully that changes. I really hope that does change for the people, and hopefully that changes, because maybe if they get their act straight and understand reputation instead of a quick dollar today, then maybe they can make something that blows our minds. But until then, I really would question it. Look at reviews, ask around, and just look for stuff that is rippable. Otherwise, I wouldn't even touch it. Otherwise, you would kill your machine, because some of those places have metal beads in it and all the other, and it's just bad day all around. That's less of a problem now, but and I think that's because a lot of these companies are figuring out, reputation does actually matter. So as far as this goes, buy only from well-known sources and whatnot. So understand that. Understand the filament that you're playing with, temperatures, size of nozzles, stuff like that, speeds, and all the other stuff. And if you're dealing with FDM, understand you're going to be dealing with heat, whereas with SLAs and stuff like that, you'll be dealing with resins and stuff. So be very careful when you buy your stuff, and make sure you have the right parts. So for example, I bought wood filament and I didn't realize it needed a 0.5 nozzle. I printed it with a 0.4 nozzle, and I've had horrible times afterwards. I'll explain a little bit more in that in a second. But because I wasn't being careful, making sure I had the right parts, I got screwed over it. And it actually did cost me quite a bit of money at the end of the day. So that's a big thing to note. Now, do not be afraid to ask questions. Yes, there is stupid questions, but do not be afraid of asking questions, because the fact of the matter is better to make sure that you have something right the first time than to have to spend a couple $100 or whatever it may be to fix whatever it is that a simple question would have, answered it. Do not cut corners. I've been personally screwed with this massively. It kind of goes into the wood filament thing, but the other thing is using pair pliers and needle nose to take a nozzle off. I destroyed a hot end by doing that. So do not cut corners. Stay away from cutting corners if all possible. Use proper sockets, use proper stuff. Otherwise, just don't do it. It's not worth spending whatever amount of money, $70, $100, whatever it is, to fix the problem in weeks and weeks of not having a printer. So that's a big thing to note. So get to know your printer, because just the tolerances and stuff can make things slightly different from yours to the next, even the same model. And this is a major thing, is understand the culture of the company that you're buying your printer from. So the big thing is a lot of these companies now, they like to test the crap out on new customers, and they'll update it and tweak it and whatever. Even Prusa, a high-end company that's it's very well known for their quality, they even do this. Basically, you'll see version 1, version 2, and stuff like that. And even if, we're talking about software, it's something to note where that's a little bit more forgiving because you will see immediate fix with the software update. But hardware, more than not, if you got to print something off, then and you don't know about it, then you can be screwed with that. Or if it's a new part, like a new type of hot end, a new type of this or new type of that, well, the thing is you can be screwed over because you simply bought something a little bit too early, even though you paid the exact same amount, and you paid the company same amount as someone else, paid them early, so they got more money, able to use your money to improve things. The thing is you get screwed over because you're earlier adopter. I wouldn't say early adopter, but just because you're slightly earlier than someone else. So a week or two early can make a difference, and that's a big thing to note. I would say stay away from pre-orders if all possible. If you want to go with pre-orders, it's fine if there's a backlog for a couple months. It might sound kind of counterintuitive, but a big thing to note is a couple months can mean that, they figured out some problems and fixed it. So, yeah, that's a big thing to note. Now, as far as the printer itself, the FDMs, we have the extruder and we have the build plates. So, as I mentioned before, the extruder goes up, whatever it may be. So, the extruder, you got different type of extruders. The direct drive or Bowden. Direct drive is basically like the following, it's all in one. A Bowden is basically where you have the this top part where it pushes the filament through. That's known as the cold area. It is it's basically on the frame itself or some other parts that's stationary, and it feeds the filament to the hot end area. The big thing to note is when it comes to this is you have oozing, you have leakage sometimes if your settings are not right. And also it's harder to print things like flex, but your prints are able to move much faster because you have less weight on the end. Basically this area, all you're concerned with is the hot end, so it has less weight overall. It's a big thing out there. Floating is a little bit different. It's I don't think it's going to catch on, but it's supposed to be the best of both worlds. In theory, I don't really know if it is, but basically floating is where you have the cold end, and it'll be attached to the top part. It's just an image that has 3 parts of it hanging from the roof, and then you have the hot end attached down here, and between there it'd be the filament goes from the cold end to the hot end, and it'll go down and to the nozzle and come out onto plates. Well, basically, I don't think this is going to take off because I foresee more problems than not, but we'll have to see. There's pictures out there of that and all that. And as far as this, basically, this just shows filament goes into this area. This is where the cold end, where all the interaction happens, where the filament gets pushed through and whatever. And then we got a hot end, and this fan right here is actually to cool down the hot end, and this fan in front is cool down where the nozzle is, so the filament comes out, it helps it cool down immediately. And then we got the nozzle down here. So as far as the cold end, this is for the MK3. This is what it looks like. This is not my picture, by the way. It's some random one I pulled off. And if you see something like that, then chances are is you are running way too hot, or the filament is bad, and you got to take a look at these things. With this, or not way too hot, but you're running this. It's too tight. Basically, what happens is these two screws, they screw into these parts, and basically there's a spring somewhere over here on these screws, and the tighter you have it, the tighter this is to this. So as filament comes through, the teeth on it will actually bite and chew onto the filament. You don't want that. You want it to just enough to push down into it. There's plenty of guides out there, but basically what you want is when you're feeding filament through is, especially with the MK3, as soon as the filament starts to feed through, as soon as you feel filament starting to feed through, that's tight enough. That's all you need. Anything tighter, you get powder and jamming and all the other stuff. The more tighter, the worse it is. Note that different type of filaments, you might have to adjust it, but still. So with that, this is the breakdown of the hot end. It'll look like this put together, but breakdown is this, and basically this is the part I saw sticking up from here, so that little bit right there, and basically it goes down, and this entire thing, this job is to heat up the filament to a certain point and then have it cool down to certain points where it will come out. Basically this entire thing is meant to have it where your filament just flows out, it's molten in here and all the other stuff. That's a big thing to note. Big reason why I got this up is you need to note this, the heat block, and the nozzle. So the thermal barrier, the heat block, and the nozzle. So as far as that goes, again, that's what it looks like at the end. When you replace the nozzle, this is the part that screwed me over massively, even following Prusa's own guides, video guides and whatnot. They kind of really didn't get into it, and part that screwed me over massively is make sure the the thermal barrier is flush with the nozzle, because what happens is if it's not, then the filament goes into the threads. It can ooze out. Hopefully it doesn't do that, but if it does go into the threads, it will mess with the cooling and heating so much that it'll create jams that are in long prints, or even small prints, depending on how bad it is. So and like, say for example, you switch from, say, brown to white, or pink to white, or whatever it may be, you'll see a little bit of that filament, and it won't stop even if you clean it out with clean filament. What the thing is that is a huge thing that messed me over, and I am trying to fix it and whatever, and also cutting corners, using pliers and needle nose and stuff like that when I should have used sockets and whatnot. That's bit me massively. So that's a big thing to note. Now you do need to have a little bit of a gap there, so that's a big thing to note, and that's to prevent heat creep. But above everything else, make sure that is flush. Otherwise you will run into some major problems. See, this, you can fix that little gap, if you need to tighten it all the way, to get flush, and then you want to run a few test prints and whatever, fine. The worst you're going to get is some jamming or whatever. You can fix that. Heat creep, it's not that bad, and you can move around all this stuff, and you can fix that. You can put thermal paste on it, and that will help fix that. But the thing is if you do not have this flush, then you might be like me and have to buy a whole new setup, or at least a new heat block, which is $10 or something like that. So big thing nuts is when buying a new printer, know if all the parts are only sold in certain countries, all or most parts. So for example, with Prusa, the hot end that I had to replace that stuff with, basically that cost me $70. It would cost me $70 over here in the United States if I bought it over here in the United States. But the problem is to ship anything from over in Europe to the United States, it costs quite a bit. It's like a $20, $50 type of thing. So it dragged that $70 all the way up to $100. So that's a big thing to note. Is it like a foreign car? Are you going to deal with a lot of proprietary crap and you have to ship everything in? or is it going to be cheap and you can just buy whatever, like say for example a hot end or a nozzle or whatever it may be, and not have to worry about it. Make sure things like nozzles that you're replacing them with is compatible. Normally that won't be much of a problem, but still worthwhile noting that. Ask around to see what is the support like with the company, and that will give you an idea if the company's worthwhile, because there's some people out there that have been open that they bought something for $1,000 and they can get any support at all, or there's other people that bought something for $200 and they're able to get all the support in the world. So ask around. Price doesn't really matter as much right here. You just need to ask, is this company worthwhile or not? And people be very vocal one way or another on that. And do your research. Do your research on that. That's a big thing. And people are very vocal, especially when it comes to negativity on that. There might be other sensors. So, for example, with the MK3, the extruder, there can be other sensors on there. So note if people are running problems, whatever, and that should tell you something right there. Try not to buy the printer kit. A lot of these companies, what they'll do is they'll have it where you can save a little bit of money by assembling it yourself. Avoid that if all possible for at least your first printer. That's a big thing that bit me in the ass, because I spent probably about 13, 14 hours building a printer, and then afterwards I spent about 2 weeks trying to fix it, and then afterwards I'm off and on, something happens, and I don't know if it's me, I don't know if it's the printer, I don't know what. So to avoid saying that, oh, it's your fault, and that way you know what it's supposed to sound like, what it's supposed to look like, how is it supposed to react, and all that stuff. Have it pre-assembled if all possible. If you can't afford it, I'll advise you to look at something else that you can't afford, because honestly, hands down, it's worth knowing what something's supposed to sound like, what something's supposed to look like, versus having to play these guessing games. Because honestly, I dealt with it, and I'm about throwing up my hands up in the air and walked away. So with that, that's the biggest tip I can give, other than that nozzle thing. Try not to get a used printer, especially with your first one. If you're a few down the line, that shouldn't be too much of a problem. But basically, you want to make sure that, like here, you know exactly what it's supposed to sound like and all the other stuff, so you don't run into some problems. Keep track of everything. So make a log, make an Excel sheet and whatnot, and that should help you out in the long run. Anyways, as far as that goes, if you got any questions, anything else, then feel free to let me know, and I'll answer as quick as possible. And by the way, I'm going to be posting a Excel sheet within the couple months, hopefully more or less, I don't know. And that should give you a head start on making your own. But basically, if you got any questions, anything else, then let me know. I'll try to answer as quickly as possible. Leave a like, subscribe, share, and whatnot, and I'll see you next video. Hope you have a great day.